Bismillahirrahmanirrahim. Assalamualaikum dan selamat sejahtera. Today inshallah we will continue with 4.3 extraction of metal from their ores. Extraction, in other words, is remove. So we want to remove the metal from their ores. Ores here is a compound. Means there are more than one element combined together chemically to form ores. Okay, so let's say the metals here we represent with red dot. Okay, here red dot, and there are many other elements that combine together chemically to form ores. Okay, let's say these are other elements. Okay, so we want to remove this metal from ores, from this compound. Extraction of metal is the process to obtain metals from their ores. Observe the relationship between the position of carbon and hydrogen in reactivity series of metals and method used to extract the metals. So, different metal to be extracted use different method. Depend on the position of metal in the reactivity series of metal. Okay, let's see the reactivity series of metals. Kalau nak cari Mimi, anak, Zain, faham, sunnah, PSP, cukup, hantar, silver, gold. Okay, so how to determine the position of carbon and hydrogen? Okay, we calculate 1, 2, 3, 4, 5. So the number 6 should be carbon. Okay, then 1. Okay, the second is hydrogen. The metals above the carbon can be extracted through electrolysis. Students have been introduced about electrolysis in Sem 1, Form 2, topic water and solution. So you already learned the basics. So I just want to recap about the electrolysis. So if students remember, in electrolysis, we must have the battery or dry cell, connecting wire, the electrode, electrolytic cell. Okay, in textbook we use a measuring cylinder. Okay, measuring cylinder. Okay, tak cantik. Apalah, as long as you understand this one, measuring cylinder. And you must have the electrolyte. Okay, this one inverted measuring cylinder. Okay, electrolyte. So the electrolyte that you have learned must be water, distilled water, and acid, any acid. So you have learned about electrolysis of water, which will produce oxygen gas and hydrogen gas. So how to remember? The shorter one here will be cathode. Short one is cathode. So cathode will attract cation. The cation will produce hydrogen gas. The longer one here is anode. Anode will attract an ion, so will produce oxygen gas. Okay, this one the basic that you learn about electrolysis. Okay, so about electrolysis for extraction is more complex, and you will learn in detail during Form 4, inshallah. For metals below than carbon, zinc, iron, tin, and lead can be extracted through reduction of metal oxide by carbon. For example, tin oxide can be reduced by carbon, okay, to form tin metal and carbon dioxide. Another example, iron oxide can be reduced by carbon to form iron and carbon dioxide. Okay, for copper and mercury, the metals can be extracted through direct heating. Means when we found the copper oxide or copper ore, we can heat directly and it will produce copper plus oxygen. Same with mercury oxide, we just direct heat the compound and it will produce mercury and oxygen gas. Okay, for silver and gold, it exists in the form of element in the earth crust. Means naturally when we found silver and gold in the form of element, means the silver or gold does not react with other element to form a compound. Okay. Process of iron extraction. The extraction of iron from its ore is carried out in a blast furnace as shown in figure 4.9. Blast furnace. Blast furnace is like a big oven. So blast furnace is in industry, so it's very big and very hot. Okay. So this is blast furnace. So let's see first. A mixture of concentrated iron ore or iron oxide, coke is in the form of carbon, limestone in form of calcium carbonate, okay, is added into the blast furnace through the top. So this all iron oxide, coke and limestone in the form of calcium carbonate. This all is in solid. We put it from the top. Okay. So next, we pump the hot air into the furnace through the bottom. So hot air, we supply the oxygen. So these are all the reactant needed or the reactant used to extract the iron. Iron oxide, coke and limestone are in the form of solid. So in blast furnace, we heat this reactant until all the solid become molten. So that's why our end product here in the form of molten metal and slag. Slag is our byproduct. So why molten iron is below than molten slag? This is because molten metal is more dense than molten slag. Next. Okay, next. Bismillah. Number 3. Reaction that occur in the blast furnace at high temperature. Production of iron. Coke or carbon react with oxygen in the hot air to produce carbon dioxide and heat. Okay, this is one of our material tadi, coke. Coke react with oxygen will produce carbon dioxide. Carbon dioxide that is produced react with the rest of the hot coke to form carbon monoxide, which is strong reducing agent. So, okay, carbon dioxide react with excess carbon to form carbon monoxide. So carbon monoxide and carbon reduce iron oxide into iron. So this one, iron 3 oxide plus carbon produce iron and carbon dioxide. So carbon will reduce the iron 3 oxide to form iron and carbon dioxide. Iron 3 oxide can be reduced by carbon monoxide to form iron and carbon dioxide. Iron 2 oxide can be reduced by carbon to form iron and carbon dioxide. Iron to oxide can be reduced by carbon monoxide to form ataupun or to produce iron and carbon dioxide. So these are the one that important for student to remember. Reduction of iron oxide by carbon. Okay. Production of slag. Slag is a byproduct from this reaction. Byproduct means the product that we don't want. Okay. Production of slag. Limestone or calcium carbonate decompose to form calcium oxide and carbon dioxide. Okay, calcium carbonate heated and it will decompose to form calcium oxide and carbon dioxide. Calcium oxide react with impurities such as sand and silicon dioxide in iron ore to form slag or calcium silicate. So impurities here means other things that impurities means other component or other compound in the iron ore. So these are the function of calcium oxide. It will react with silicon dioxide to form calcium silicate. So slag is general name. So chemical name for slag is calcium silicate. Focus on this part, okay? Okay, student can see here, this one, number 1, where all the solid reactant put from the top. Number 2, hot air from the bottom, where this is how the oxygen supply into the reaction. Number 3, where the process occur. This is where the reaction take place. Okay, student focus this part. Metal oxide react with carbon to produce metal and carbon dioxide. Okay, number 4. Okay, focus on number 4. Okay, where the product produced at the bottom, molten metal release, slag is released. Okay, we focus on number 4 now. At high temperature in the furnace, iron that is produced will melt. This molten iron flows to the bottom part of the furnace. From time to time, the molten iron is tapped off and channeled into molds and allowed to cool and freeze. The molten iron that has solidified is known as cast iron. Slag that is produced will melt. This molten slag also flows into the bottom part of the furnace. Since molten slag is less dense than molten iron, the slag will float on top of the molten iron. From time to time, the molten slag is tapped off and used to make the base of building and roads. So that's why the molten slag above molten iron, because molten slag less than molten iron. Bismillahirrahmanirrahim. Many issues in Malaysia and their impact on life in the local or global context. Local context here refers to community or country, while global context refers to international or universal. Okay, so many issues in Malaysia, they are divided into local context and global context. So let's see. Water pollution due to cleaning of ore is one of example of global context. So how to reduce water pollution or prevent water pollution? By reduce or eliminate hazardous materials that enter the production process. So air pollution, there are two issues regarding air pollution. They are example of global context. So one, air pollution due to burning of fuels. And another one is air pollution by gases released from blast furnace. So how to reduce this pollution? By filtering the gas produced before releasing to the atmosphere. So next, soil erosion due to mining of ore, example of local context. So to reduce this problem is by replanting trees. Sound pollution is a noise or unwanted sound example of local context. Okay, sound pollution from mining machinery. So how to reduce or to prevent the pollution is by use noise absorbent, plant more trees as they are good noise absorbent, or for workers, use earplug. So usage of large amount of electrical energy is example of local context, and destruction of habitat due to construction of mine also example of local context. Okay, as homework, pause the video, copy the question and answer in your notebook.